Alright, so this whole first page is review, hopefully. And we're talking about inverse trig functions. And the inverse of sine is called arcsine, and sometimes it's written as written like that. But that's not to be mistaken for the -1 power. So that's inverse, just like f inverse. So we want to make sure we don't make that mistake. Now, the thing about the inverse trig functions is we have to pay careful attention to the domain and the range. So what I've done over here is started with sine, and sine normally goes from -1 to 1 on the y-axis, and then this is pi and pi over 2, etc. So that's the normal graph of sine. Now you can see at pi over 2 I stopped and I started putting dots, and when I got down here to -1 at -pi over 2, I also started putting dots. So the problem is that if we think about the horizontal line test, once we pass -pi over 2 and once we pass pi over 2, we would start repeating values. We would fail the horizontal line test, so that would not be 1 to 1. So to look at the inverse trig functions, we need to chop them off and just look at a certain section. So if we think about this here, remember that when we find an inverse, we switch the x and the y. So we switch the domain and the range. So if you think about it, so if we want to get the domain of the arcsine, what we would do is we would look at the range of sine. So the range of sine is -1 to 1. So if we flip that over, then that would be the domain. So now the domain would be -1 to 1 instead of the domain of sine. The domain of sine is, if we're chopping it off so that it's going to be its inverse will be a function, would be -pi over 2 to +pi over 2, which is what we get when we move over here to the range. So now the domain, the x values, become the y values of our inverse function. So that's going to be -pi over 2 to pi over 2. And those are both with brackets because we do include the endpoint. We also can write that in this notation, so we kind of want to be familiar with both. And you could do the same thing over here, but I'm not going to. I'll alternate, maybe. Or maybe I'll just do interval notation. Okay, so that's all I have there. Now, if we think about it, if we go on to cosine, so I don't want to graph all 6 of both of these. That would take a lot longer since this is kind of review, should be review. So if we think about cosine, so cosine would start at 0, 1, and if we tried to use that same domain and range, well, the range will be the same from -1 to 1, but we can't use the same x values here because if we tried to go from -pi over 2 to +pi over 2, we would fail the horizontal line test. So here we're actually going to start at 0. Okay, well actually the domain of cosine will be the same. Okay, one more time. The domain of the arc's cosine or inverse cosine is going to be the same as the domain for sine. So that's also going to be -1 to 1. So what's going to change though is the range. The range, like I was saying, can't be from -pi over 2 to pi over 2 because it would fail. It looks like a parabola sort of, and that would fail the horizontal line test. So what we need to do, we're going to shift that over and we're going to start at 0 instead. So we're going to start at 0 and we're going to go all the way to pi for cosine. So we can graph that over here. Now, so it's a little bit trickier. So if you think about it, we were at 0, 1. So now it's a little bit awkward, but this is pi over 2, and this is -pi over 2. And if we think about, except that we're doing, so -1 to 1. Alright, so I'm changing the scale on this one, so don't compare these two graphs exactly here, but So this is going to be pi over 2, and then this is going to be pi, and then I move the negative 1 and the 1 over more. And again, also this scale is by halves, and this scale is by pi over 2. So these they're not the same scale, so it's not going to work out that well if you try to compare them that way. But so if we plug in negative 1 for arc cosine, if you think about the graph of cosine, that's when cosine of pi, the cosine of pi equals negative 1. So that is going to be up here. And then that's going to come down to here, and then down to 1 like that. Alright. So some of that's kind of hard to see. You can kind of maybe memorize what's happening there. So tangent is at 0, and then we have an asymptote at pi over 2. So we could do this, and then at pi, or I could use this as pi over 2 here, but okay, so pi over 4 would be 1. So we're just going to take that one section of tangent, because if we try to take another one, if you remember, I don't know if you remember, but tangent just repeats over and over again those same things. So here, if you think about the range of this one, it goes to negative infinity and positive infinity, so that's going to be the domain of our inverse. And then if you think about the range of the inverse tangent is going to be the domain of this, and the domain of this was negative pi over 2 to pi over 2. Now, another difference here is that they're parentheses, not brackets, because those are asymptotes. So that's not going to work for us there. Now, if you think about arc cotangent, hopefully you realize that domain should be the same. So cotangent is just shifted over, and it goes from 0 to pi, and it goes this way instead. So maybe I am just trying to give you a better picture of that. So that's going from 0 to pi. So you can see some things that kind of match up here. So these kind of go together, and these go together. And these two went together, and these two went together. So there's some overlap there. So now thinking of the graph of cotangent might be a little trickier. So if you think about that, if we switch, this was pi over 2, 0. So that's going to go here. This is going to be pi over 2. This is going to be pi up here. And I'm going to stretch this out also. Well, it doesn't matter that much, but so here we're going to have that asymptote up here. That's going to come down like this, and then go down here. Okay. Again, the graphs, I don't know if it helps you, if you're more visual, that's good, but if you can memorize them, and you may be able to get by without being worried about too much. But anyway, let's finish these last two off. So arc secant. So the way I graph those is I think about what goes with secant. That's cosine, and cosine would normally be right here. So what I normally do is I put that in kind of as a dotted line to help me graph those. And then what's going to happen there is the graph we have the same problem we would have with cosine. If I try to go here, I'm going to get a parabola looking shape, and that's not going to pass the horizontal line test. So we need to chop it off here like so. So this is going to be pi over here. So we're just going to take, so there's going to be an asymptote here. So we're going to take this graph, that half of that, and then over here we're going to take this half. And so that's the graph of secant where we're chopping it off so that it passes the horizontal line test. And so now we're going to flip those values. So now if you think about it, so the range of this is going to give us the domain of our inverse function. So that's going, what's the lowest it could be? It could be negative infinity. So it starts at negative infinity, and then it works its way up here to -1. And then it picks up again at 1 and goes to infinity. Alright, now if you're trying to write that the other way, you'd say x is less than or equal to -1, and actually I don't know if you probably wouldn't use that union sign actually. I don't know if you can, you might be able to, but I'm going to leave it. Alright, and then this one would be x is greater than or equal to 1. And now if we look at the domain of this, that'll become the range of this. So the domain is starting at 0, and that is included. And then it goes up to pi over 2, but there's an asymptote there, so we're not going to include that. And then we'll pick it up again on the other side, and that's going to go to pi. And that's fine. So now the way I would write that would be 0 is less than or equal to y is less than or equal to pi, as long as y does not equal pi over 2. So as far as the calculus test, this shouldn't come up on the AP exam in this way, but where did I skip blue there? Blue, yellow, green, purple. Okay, not sure. So if we look at our cosecant, that goes with sine, and sine starts at 0. So if you think about that one, I guess I'm going to think about these graphs here. So sine starts at 0 and goes up like that and down like this. So that's actually okay there, because we'll get this, I should have done that as a dotted line. We'll get these two like this, and that's okay. So the domain, hopefully you notice, is going to be the same. Because we're not including that -1 to 1 there. So that's the same on both those. Now the range is shifted over here. So that's going to be -pi over 2 to 0 and 0 to pi over 2. Okay. Okay, so that graph, if you look at this, these are going to get reflected, so that's going to be here. So it was 1 and it was pi over 2 and 1, now it's 1 and pi over 2. And instead of going up this way, it's going to come down this way. And then over here, we're going to get kind of the same thing. It's going to go like that. Okay. So let's move on and see what we have to do with that stuff. So that was a lot of introduction, actually. So we just we want to go backwards, but we also need to think about the domain and the range. So arc sine. So the first thing you want to think about there is that we need to stay between negative pi over 2 and pi over 2. So root 2 over 2, if you think about that, another way to think about this is the sine of what angle gives us root 2 over 2. But you need to stay on the unit circle, you need to stay between negative pi over 2 and pi over 2. So that's positive, so that's going to be up here for sine. Sine is a y value. and root 2 over 2 is 45, so that's going to be pi over 4, and pi over 4 is in there, so we're good. Okay. Now for arc cosine, so that's different, so that is up here. Okay, we go from 0 to pi. That's what we want to focus on. So negative cosine is x, so that would be over here, and negative, and again it's still 45 degrees, so the reference angle is 45 degrees, but so now that's going to be 3 pi over 4. And so there's just little details, like that's not in the domain over here, so we have to be careful. Again, when you think about the domain and the range, like I'm switching, I'm thinking of it this way, so it's a little bit different. But alright, so next thing is what you should see here. These are inverses. So as long as that value works here, that is between pi over 2, negative pi over 2 and pi over 2, which is what we need to look at for sine. That's going to be okay. So pi over 7 is fine. So remember, inverses basically nullify each other. Okay, now the problem here is that the domain for inverse sine, and I've written some as arc and some as inverse just to get used to both symbols. So the domain is negative 1 to 1. So this is the empty set. So sometimes people draw a slash with 0. We don't want to do that in math because that means the empty set. That means there's no number that satisfies this situation. This is not working out for us. Alright, these last two are actually equations, so we're not just simplifying or reducing, we're actually solving these. So here, one thing we could do is we could take divide both sides by 6, and then we would have the inverse tangent of x equals pi over 6. So what we could do with that is we could take the tangent of both sides, because those are inverse operations here, and that will basically just give us x. So now we need to know the tangent of pi over 6. Now you could do that one of several ways. The way I do it is I just kind of have these values memorized. So down here in the bottom corner, I know that the tangent of 30 degrees is root 3 over 3. I know the tangent of 45 is 1. And I know the tangent of 60 is root 3. And I think of this little pattern here, there's a lot of 3's. And I know that 60 degrees is more than 30 degrees, so root 3 is more than root 3 over 3. So I just kind of have this memorized. So if I have to do tangent, I just kind of jot that down real fast so that I can look at it and I feel more comfortable with that. So the tangent of pi over 6, 30, that's root 3 over 3. Okay. Now over here, you want to be careful. So we're looking at first, when you look at that, you think, oh, those are inverses of each other. We're going to be okay. But what we need to focus on is that we need to be in between pi over 2, negative pi over 2 and pi over 2. And this is not in between here. So that's another example of an empty set there. That's not going to work out for us. And we still haven't done any calculus yet, but okay. So again, here, same thing. So I'm going to take the sine of both sides. So that is going to be that. And the sine of pi over 6. Pi over 6 is 30. That's a small angle. Sine is the y value. So that's the small number. That's smaller than this. The y is smaller than the x. So that's going to be, the small number is 1/2. So if we add 1 to both sides, that'll be 3 over 2. And then multiply both sides by 1/2. So that would be 3/4. Alright, so let's see if that takes us to some calculus. Not yet. Okay. So in the pre-calc class, I remember in the book there were a couple of examples where they had you mess around with this stuff. And the reason was kind of to lead up to what we're doing now. So one thing to think about this whole thing, all that whole first page, is that inverse trig functions are angles. Okay? So now, let's take a look at this example. So find the tangent. So tangent, SOHCAHTOA, tangent is opposite over adjacent. So that would be x over 1. So that would be x. So the tangent of theta equals x. Okay. So then it says find the inverse tangent. Okay, so remember, we just said that inverse trig functions are angles. So that would be theta, would be the answer to that. Now it says find the hypotenuse as a function of x. So that's going to be the Pythagorean theorem. So that's going to be a squared plus b squared equals c squared. But it said to find the hypotenuse in terms of x. So we're going to take the square root of both sides. So that's going to be right there. Alright. Now it says find the sine of the inverse tangent of x as a ratio involving no trig functions. So this is an angle. We just talked about that, and it's right here. So that's theta. So what we can do here is we can just evaluate this as the sine of theta. And if we go up here and we do sine, sine is opposite over hypotenuse. So opposite would be x, and the hypotenuse is right here, 1 plus x squared. Okay. And that brings us back to this last one. So again, that's an angle. So we're looking at the secant of theta. So the secant of theta is the reciprocal function of cosine. So we can focus on cosine. So cosine is adjacent over hypotenuse. So that's going to be 1 over this. And if we multiply both of those by this, that'll cancel out down here, and that'll give us that up there. Alright. Oh, I just said that down here. So the point of that is that we did not have to solve for the angle itself. We never figured out what that angle was. Okay, let's keep moving so we can get to some calculus here. I should have told you if you were really good with this inverse trig function, you could try to get through this pretty quickly, but alright, excuse me. So, always think of the restricted domain, so you want to make sure you keep that in mind. Okay. So, for arctan, we go from negative pi over 2 to pi over 2. 1/5 is positive, so that's going to be in the first quadrant. So when you have this information, that will help you think about where you're going to be. Alright, so we want the cosine of the arctangent of 1/5. So that is the angle. So we want to focus on using that. So what that's telling us is the tangent of theta equals 1/5. So what that's telling us is the opposite over the adjacent is 1/5. So we have that. Now if we do the Pythagorean theorem there, so we're going to have a squared plus b squared equals c squared, so that's going to be root 26. So now we're taking the cosine of this angle. So we're using this to fill in the sides, and then we'll go back and do cosine. Cosine is adjacent over hypotenuse, so the cosine of theta is going to be 5 over root 26. Alright, and last one down here before we get to calculus. Okay, so let's see. I want a triangle here. So now we're talking about cosine. So if we think about this as theta, put it right here. So that's going to be, cosine is adjacent over hypotenuse. So we could put 4x over 1. So if we do the Pythagorean theorem, we have a squared plus 16x squared equals 1. So that's going to be 1 minus 16x squared, and we take the square root of both sides. So that's going to be 1 minus 16x squared. Alright, and now if we do the sine is opposite over hypotenuse. So that's, I need to add a square root on there still. So that's actually the answer, because it's going to be that over 1. Okay, so we may need to do some of that to set something else up, possibly. Okay, finally, calculus. After all that time, get a little bit of calculus here, one page on the back. So this we just need to memorize. So usually there's one of these on the AP test, so if it becomes too much for you, it's not that big of a deal. But so how do I memorize these? So first of all, I see that I have u prime and all of them in the numerator, and so here's how I do that. So sine, well, we normally do SOHCAHTOA, right? Sine comes first, and so I remember that 1 sine comes first. So in the formula, I have u prime over the square root of 1 minus u squared, because sine comes first. So that's how I remember that. Tangent, I remember that that's no square root. So, and it's a plus. So tangent, no square root, and it's a plus in there. I just memorize that. Okay. Now for secant, inverse secant, I should have inverse sine, inverse tangent, inverse secant. What I think of here is that it's a switch. So I'm switching these two. And there's an extra absolute value of u. So again, I'm trying to memorize all three of these together. And then the cofunctions, the ones that start with the letter C, they all match these except they're all negative. So that's just one extra step. Once you have these memorized, you memorize, oh yeah, the cofunctions are the opposite with a negative out in front. Okay, so we can try to start memorizing those right now. Alright. So this last page looks a little bit long, but it's not that bad because this stuff down here is just a little bit of an explanation of, or not explanation, but a little more detail. So really all we have left are these couple examples here. So first of all, take the derivative of arc sine. So if you go back and you have tried to memorize that, so that was u prime. They all have u prime in the numerator, so that shouldn't be a big deal. And all of them have square roots except for tangent. And sine comes first, and so there you go. And we're just practicing that. So now we have the derivative of u, which is going to be 3x squared over the square root of 1 minus, and then we just square this. So x cubed squared is x to the 6th. So not horrible. You got to memorize that. Okay. So now if we move over to arc secant, cover this up, and I can think about that. So arc secant is also u prime, and it's not a cofunction, so it's not negative. I probably should change that to cosecant, but that's okay. And then we have an extra absolute value of u for the secant and the cosecant, and square root, and then remember it switches. So sine was 1 minus u squared, so now this is going to be u squared minus 1. Okay? So I'm writing that out to practice it, to try to memorize that. So you get out a blank sheet of paper, write that down a bunch of times until you have it memorized. So now the derivative of u, that's just going to be derivative of e to the x, just e to the x. Okay. Then down here we have the absolute value of u, which is e to the x. And then here we have u squared, so that's squared, so that's going to be, I guess I'll write it out this way. So e to the x squared, and then minus 1. Okay. Now if you think about this, e to the x is always positive, so the absolute value here is not really that big of a deal. So this is basically going to be 1. So we're going to have 1 over, and then here this is going to be the square root, and when you have a power to a power you multiply, so that's going to be 2 times x minus 1. Okay, so not that bad. In your notes, there might be this number might be wrong. I think I inserted this from another part of the notes, and so you might want to just white that out. And this should be example 6. Not a big deal. Okay. So this is a limit question, but we should be able to use direct substitution here. So if we have the inverse tangent of x, we take the limit as that's 1. So remember, inverse trig functions are angles. So the tangent of what angle equals 1? Well, that's going to be pi over 4. 45 degrees, that's when sine and cosine are equal, and tangent is sine over cosine. So this really kind of goes back to chapter 1 using inverse trig functions. And then down here we have the inverse of sine. So the sine of 1, so the sine of what angle equals 1? So that's pi over 2. So we have pi over 2 plus 1. So it's a complex fraction. So we're going to multiply that by 4 over 4. So that's going to be 2 pi plus 4. And there we go. And like I said, the stuff on the bottom is just some details. So that it's about that time. Have a good day.